Hello, CS11. Welcome to Lecture 25. So in Lecture 25, we will mainly be going over file I/O, that's file input output, context, not the context I mentioned in the decorators lecture, a different kind of context, as well as enums. So out of these three topics, enums are going to be the one included in Hope 3. So yeah, we'll go through enums towards the end. Alright, so by the time you're watching this lecture, hopefully you are going through these practice sets as well as the 3 lab exercises for this final arc. Okay, so from the project, you should already be familiar with file I/O. What we're essentially going to do in this lecture is go through the inner details of what's actually happening when you are doing your file I/O. Okay, so far, outside of the project, we have mostly been just reading from and writing to the terminal. This screen over here. So again, in order to take input, use the input function here. So line is input. So it's going to prompt me for an input. Let's say Daryl. So once I have that line, I can print it out over here. So that is how we have been doing input and output so far. You can also do this with files instead. So for files, how we do that is with, then let's open a new file, hello.txt. As file, what we're going to do here is we're going to take line is equal to file.readline. What is happening over here? So by readline, you should be able to tell that what this is doing is it's reading a line from this file over here. File here, this file variable is this one. This refers to the file hello.txt. So if we do that, now I haven't actually written, or I don't have the file hello.txt yet. So actually, let me quickly go to a different window. Then in hello.txt, I am a line. Okay, so if I run this now, okay, and print the first line is then line. So the first line is I am a line. So I am a line here comes from the contents of this file over here. So that is how we read from a file. So here we have new syntax. So we have with, open, then a file name, as, then the name of the variable referring to the file. Okay, so what is this with thing over here? This with thing over here is what defines what we call a context. So we'll go over what a context is shortly. So why do we need with in the first place? So let's try doing all of this stuff manually first. So let's say file is open hello.txt. Okay. So then we do the same things. Line is equal to file.readline. Then I'm just going to print the line itself. Let me do that. So here, as you can see, I get the output that I expect. So why do we do with instead of doing just these lines over here? Okay, so notice here that aside from these 3 lines, we also have a file.close. Of course, well, as you continue programming, you will realize that whenever you open a file, you also have to close it. So this is kind of a form of cleanup. Whenever you open something, you have to close it. So file.close. If we try to read from the file again, let's have that. You'll see here that that's no longer possible. You're doing an I/O, or you're reading a line from a closed file, which you can't do. So the proper way to work with files is to close them after you're done using them. Okay, so let's understand what happens when you run a program. Okay, so when it comes to running programs, your computer, this thing I'm using right now, can only run one program at a time. So for example, let's see what I have open over here. This is preview, what I'm using to view this PDF file. This is a single program. This is what I'm using to record this lecture. And this is my terminal. So these, you can think of these as programs, their own programs. Our computer can actually only run one of these programs at a time. And whenever your computer is running programs, it's doing so via the operating system, OS. So the OS is basically a different program. It's a program that runs other programs. So you can think of it as a kind of meta program. It's a program that's able to run other programs. So this is why you can actually see all three windows are open over here. Your operating system does some magic in order for me to be able to switch between my terminal and my PDF viewer. Okay, so there, that is what my operating system is doing. Aside from running programs, your operating system also manages what we call the file system. So whenever you, for example, let's list out the files here. Let me go back a folder. Let's say I list all of these. All of these files and folders over here are part of what I call my file system. So in relation to the file system, the OS is also responsible for what we call security. So multiple programs should not interfere with one another. So my PDF viewer shouldn't interfere with my terminal. So yeah, the OS is basically what handles all of these inner details of, let's say, the file system, running programs, as well as security. So for more details, you'll be seeing this in the OS course, CS140. So this is in your third year. So around 2 years from now for the CS people. Okay, so back to files. So whenever you run a program, your OS allocates a portion of its memory for that program. So again, if I have these three programs over here, each of these is allocated a certain portion of memory by my operating system. So you can actually see that over here. Let's go to activity. This is my activity monitor. And if I open that, you'll see here, these are all of the processes. You don't need to know what a process is. You'll go over that in CS140. And for each process, you'll see here there's a process for preview, one for my terminal, and where is the one for, there, my recorder. So each of these is allocated a certain amount of memory, this megabyte stuff you see on the right. So this column shows you the amount of memory allocated to each process over here. So in Linux, I think there's something similar. Try to search up how you can find the activity monitor equivalent of Linux. If you're using a Mac, it's the activity monitor. Okay, so back to the lecture. So again, each program has its own fair share of memory. And in that memory, what is stored is all of the variables, lists, etc., etc. So for example, this terminal program has its own variables, lists, and so on. Okay, so the OS prevents different programs from interfering with each other's memory. So this, let's go back here, the 500-ish megabytes can't be used by other processes. It's only exclusive to whatever process it's allocated to. And yeah, as we've seen, the OS provides ways for our programs to read and write the files. In the case of this Python program, let's go back here. In the case of Python programs, it's the open and close we saw a while ago. Okay, so in Python, open is for opening files, close is for closing files. Now the problem with open and close is that if you forget to close a file, let's say you just, Python 3. Let's say you have a file which you open, hello.txt. This hello.txt. Oops, I'm in the wrong folder. Let's go back to lecture 25. Let 25. So let me do that again. File is equal to open hello.txt. If I try that and I do some stuff with it, then I forget to close it, then if you're not careful, then that file might get corrupted. So this file here, although it's not corrupted here, if depending on what you do with, let's say, your terminal, it might get corrupted if you forget to close the file. Okay, if you want to look into other specific issues that you might encounter, you can look into this Stack Overflow thread over here. Okay, so back to this program here. So the only difference here is in the second line, I'm converting the first line I read into an integer. Can you tell what is wrong or what can go wrong with this program? So there, if the first line, for example here, if this isn't an integer, then you are going to run into problems. So let's do that again. File, open hello.txt. If I try to, line is equal to int file.readline. If I do that, you'll see that I get a value error. Depending on, let's say you put this inside an actual Python file. If you run this, it's going to stop here since it's already going to raise the value error. So in that case, it raises a value error, then it stops before it closes the file, which is problematic. So in other words, you need to structure this in such a way that you always remember to call close whenever you call open here. So there. So you need to structure it so that you always close files that you open. So this applies for any case that happens, whether you exit, you exit something, you run into an error, or something else. Okay, so in order to deal with that, by dealing with that, I mean you don't have to remember to close every single time. That is what the with statement is for. So Python has the with statement so that you can both open a resource, then once you are done using that resource, you can wrap up what you are doing. So you can wrap up or clean up that resource once you are done using it. So this will happen, this cleaning up will happen no matter how your program ends. So even if you run into an error, it's still going to close the resource properly. Okay. So in the case of files, what that means is that whenever you open a file, once you exit the with block, it's going to call close automatically. Okay, so it will look something like this. So the file is open throughout the with block, and once you go outside, it's going to be closed. Okay, so there. That is how you open and close files safely. So even if you return, for example here, inside my with block, I return true inside here. Even if you return, it's still going to close this file properly. Okay, even if you run into an error. For example, if this gives you an assertion error, this is still going to close the hello.txt file properly. Okay. So again, with statements are generally used when you want to work with what we call resources. So what is a resource? Some examples are, well, files, as we have seen. Other examples are website connections. So whenever you are opening a website, you're actually establishing a connection with that website. That connection can be opened and closed. If you access the website, that connection gets opened. Once you, for example, close the tab for that website, that connection gets closed. So aside from websites, you can also connect with other computers. So you can also establish connections with other computers. That's another kind of resource. What else? A database connection, as well as transactions. So for those in CS, you'll see this in CS 165. You can also establish connections with databases. Okay, so the common thing with all of these is that they have to be closed, which is why we can use with for them. So most resources already know what to do, or in other words, they have their own equivalent to the close for files. So all you need to do with them is use with when you are using them. Okay, so in order to make our own contexts, one such way is something like this. Again, you don't need to know how to do this, but in case you're curious, this is how you would implement your own or support your own resource. This is where you put the opening part. This is where you put the closing part. So to do that, you'll need to import the context manager decorator from context library. So there, if you have this, you can use it like this. Okay. So that is for with statements. Let's go back to files themselves. What other ways can we read a file? So we've seen that we can read a single line. If we do that again, we'll be able to read the next line. So let me populate this with several lines. Okay, so another line, yet another line. There. So let's save this with open hello.txt as file. If I print file.readline, I'll get I am a line. If I do it twice, you'll see that I get I am a line. This is the first line. Then the second line is I am another line. So read line always reads the next line. So aside from that, you can also read a certain number of characters. So here, let's say I print file.read, let's say 100. So this is going to take exactly 100 characters from this file. And if I want to read the rest of the file, or the entire file, print file.read. This will give me the entire file here. Okay, so other ways, if you want to get all of the lines of a file, you can use read lines. Instead of printing out all of the file as is, this will, let's read lines instead. This will give you a list of strings, where each string ends with a new line character. Okay, so similarly, you can iterate over a file. So if we have for line in file, print a line. If we do this, we will have each line over here. Note that there's a space because there's a new line from the actual file as well as a new line from the print function, which is why it looks like this. Okay, so try not to read large files in memory since that might make your program slow. In general, reading and writing from files is relatively slower compared to most of the other operations we've covered in CS11. So try not to read really large files. Okay, so speaking of files, there are generally two kinds of files that we work with as programmers. Text files as well as binary files. So far, we have been reading text files. So this is a text file since it contains normal characters. For binary files, as you can tell, binary files since they are using binary. So for that, it's a slightly different process. Instead of reading it like this, what you would do here is you need to add in a additional parameter here. So there. I believe you can look this up. Let's try to open. So here there's a mode here. In the mode, you can specify whether you are reading a binary file or not. So here, the B is for binary mode. So if you want to read from a binary file, you would have R and B. So you would do open, name of the file, then mode is equal to RB. So that is for open. Alright, so what do we have here? We have two programs that do the same thing. But for this first one, this last line here is part of the with block, while this second version, the last line is outside of the with block. Which one of these is better? So generally, if you're reading the whole file, it is better to process the data that you get while the file is closed. So in other words, assuming you're reading this entire file in one go, it's better to minimize the amount of stuff you put inside the with block, the right part over here. So do the processing outside of the with block. Okay, so don't keep many files open at once since you might run into issues with your operating system if you open too many files. So the only reason you would really want to do something like this is if you can't read the whole file at once. So if the file is really that large, then you don't have a choice. So aside from reading files, you could also use this if you are reading a stream. Remember from one of the lab lectures, a stream is either standard input, standard output, or standard error. So input and output is with the terminal. Error is also in the terminal, but it only happens if you run into an error. So these are the streams we're talking about here. Okay, we've talked about reading from files. What if we want to write to files? If you want to write to a file, we need to open it in write mode. So far, how we have been reading from this hello.txt file is in read mode. So what's actually happening when we're doing this is we have this as read mode. The R stands for read. If we want to write instead, we need to add W as a second argument. So W as file, then here, if you want to write to this file, then you can file.write, then write some line over here. Note that if you write to a file, it's going to wipe out the file. So be careful if you open this line itself will already wipe out the file, so be careful. So let's say file.write I am a new line. There. So as you can see here, our file now contains this line over here. Okay, so again, just like with reading, there are several ways to write to a file. One is by using write, as I've shown. For this, whenever you are writing a line, make sure that you explicitly indicate new lines. For example, if I do this, another line. If I write like this, you'll see here that both lines are in the same line. If you want to separate these with a new line, you have to explicitly indicate the new line here. So if I do that now, if I do that now, I should get the two lines I want here. So you can also write to a file using the print function. So remember, when we went over keyword arguments, we said that print can take in a keyword argument called file. And this is the purpose of that. So using the file keyword argument, you can indicate what file you want to print into. Okay, so again, make sure you add new lines if you want to. Now write itself is more low level than print, so that's why you need to indicate the new line. Okay, so aside from that, you can also open multiple files. So let's say you want to read from a file, then write to a file. You can do that. So that's put a open as here, open as another file over here. So if we have both of these lines, you can access both the source file and the target file inside the with block. So that is how you work with multiple files. Okay. So, but instead of this, as much as possible, try to only open one file at a time. So again, simple is better than complex. Work with one thing at a time. Okay, so how about for the terminal? So from the lab lecture, you should be familiar with streams. So again, input and output with the terminal acts like streams. So streams themselves are actually files. So they can also be represented as file objects in Python. And in order to access those files, for example, remember that file is equal to open hello.txt. This gives me the file variable. The variables for standard in and standard out can be imported from the sys module. So again, standard in is for reading from the terminal, standard out is for writing to the terminal. And whenever you use the print function, you can pass in these variables over here to indicate that you want to read from standard in or write to standard out. So are these actually files? It's both a yes and a no. In terms of, at least from the OS's, the operating system's perspective, they're not strictly files, but from our end, as Python users, yeah, they are represented the same way as actual files. But at the end of the day, in terms of how we're going to use it, it doesn't really matter for our purposes. So remember, we covered duck typing in one of the lectures. If it walks like a duck and quacks like a duck, then it's a duck. So essentially, both std_in and std_out are duck typed. So they work the way we expect them to work, which is how we want to use them. Okay, so note that what you open is not limited to files. You can also open from folders or from other paths. So opening from a folder is also valid. Okay, but note that there's a caveat here. If you're using Windows, the way they separate different folders is not with a forward slash, but a backslash. So this will work on Mac and Linux, but it probably won't work on Windows. So how do we fix this? How do we make this more portable? So for that, we have the OS library from the standard library. We have the separate and the join functions. So just like with strings, they can separate a path as well as join multiple parts of a path into one. So this is how you would use that. So if you do os.path.join, For Macs and Linux, this is going to return this, while for Windows, it's going to return a different thing. So this is a OS-dependent function. It returns different values depending on what you are running it in. Okay, so this is one solution that works, but a more modern solution is to use the path library module. So the way that works is you import the path from pathlib, and here you make a path here, then here you add slashes, then you're essentially putting together the folder path, the folder 2, as well as the file hello.txt. Then once you have that path, you can use it normally inside a with statement. So as you can see here, we used a / a division symbol, to join two strings together. So it uses the division operator to act like file separators. How is this legal? So how can you divide a path by a string? As it turns out, this is one example of what we call operator overloading. It's essentially implementing the behavior of the division symbol if what you are dividing is a path as well as a string. So the custom type path has its own implementation of the division operator, which is why you can do stuff like this. If you think about it in a more broader sense, operators in general are actually just methods. Remember from classes, data classes, each data class has a list of methods you can use for it. Operators, you can think of them as methods for example, the integers. So let's go here. Plus is essentially an operator for the integer class, for example. So you can overload operators for most classes. So for example, plus, minus, times, divide, and so on. You can also overload other operators like in, equals, not equals, and so on. Now how you actually do that is not for CS11. Note that some operators can't be overloaded, just like these. So you can't overload the Boolean operators here, as well as the is keyword. Okay, so how do you actually overload operators? That is going to be a topic for CS12. So you won't go over that in CS11. Okay, so that was operator overloading. But yeah, essentially that's also what we're going to go over for file I/O. So hopefully you're now familiar with what's actually happening when you are doing stuff like this in the project. Alright, so that is for files and operator overloading. Let's go to the last topic, enums. So to motivate enums, we're going to have this motivating problem. How do you represent the 4 directions, north, south, east, and west, inside a Python program? Now, how you would normally do it is probably something like this. So you have a dictionary that maps strings to tuples. So for example, north is mapping 0 then +1. South is for 0 then -1. This is x and y coordinates. East is for +1 0. West is for -1 0. Now what is the main issue with doing something like this? The main issue is that, well, this is actually prone to typos. So for example, you might type the keys incorrectly whenever you are using this dictionary over here. So how do we go around that? Another attempt we can do is to use global constants. So instead of using strings as our keys, we can use variables. So north, south, east, and west. And their values are still the same as before. Now, what is the main issue we'll run into if we use global constants instead of strings? Well, here it's actually, well, something like this. Whenever we make whenever we make representations of north, south, east, and west, we're only using 1, 2, 3, and 4 as, well, keys for this dictionary. We don't actually want to say that east is equal to 3, since that doesn't make sense. We just want east to represent its own unique value. It doesn't even have to be 3. So how can we make values that are separate from each other and are also separate from some of the common values that we encounter? So one way is to make a custom type which has exactly 4 values. So we want a custom type, let's say it's called direction, which should have exactly 4 values. And that is exactly what enums are for. So if we have the enum here, so how we make an enum is import enum first. From enum, import enum. This is a class. Then here, we'll have class direction. Then this wraps around enum. Then here, this is where you put the north, south, east, and west. South, east, and west. So that's how you make your own enum. So now if you want to make this dictionary over here, you can use these enum values, direction.north, .south, .east, .west. So if you try to access direction.north, you'll see here you get essentially an entry inside this enum. It says that dir.north is assigned the value 1. So don't worry about this syntax yet. You don't need to know what's happening when we're wrapping around enum here. Just know that this is how you make your own enums. Okay, so using this implementation, we now have exactly 4 values for direction over here. Also, if we try to, for example, compare north with 1, you'll see now that this is false. When you compare this with this is an enum entry. And an enum entry is treated differently from a value, which is why this now gives us false, which is more natural. Okay, so since another advantage is that we can use dir as an actual type. So for example, we can type this with the dir enum is equal to dir.north. So this is valid. If you try to do stuff like this, if you run this through your type checker, this probably won't work. This is still running since I'm in interactive mode. If you run a type checker on this, it should give you an error. Okay, so each of the instances here has its own name as well as a value. So you can access those, the name and the value, using the .name and .value attributes of each entry here. So d.name here will be equal to east, the string east, then d.value is equal to 3. If we want to get the specific directions with names and values, in other words, we want to map this name and this value to dir.east, we can do this for the name and this for the value. So it's brackets for the name. So let's say we have dir, then let's say we want north. This will give us dir.north. If we want the value, we use parentheses. So dir, let's say 1. This will give us north. So again, brackets for the name, parentheses for the value. Alright, if you want to iterate over all possible directions, you can do that normally. So this will iterate over the entries of the enum dir, and you can access their name and value as usual. Now, if you don't actually care about what values these get assigned to, here there's not really a specific reason. We want north to be 1, south to be 2, and so on. If we don't care about what values these should take, we can also use auto instead. Auto will automatically assign a value, a unique value, to each of these entries. So yeah, that is essentially how you would make your own enums. So again, you use it using the class keyword, wrap it around enum, then assign each possible value to auto, or a specific value if you need one. So these are other examples in which how you can use enums. This is for colors, and this is for difficulty levels. For statuses, for example in OJ, this is how you could represent those statuses using an enum. So yeah, enums allow you to represent multiple unique things without explicitly making them equal to common values in Python. So that is for enums. And yeah, that is actually the end of this lecture. So by the time you're watching this lecture, the Hope 3 should be pretty soon. So hopefully you are going through each lab and practice set. Now the reading from this lecture onwards is going to be more of a preparation for future CS courses. So one really good book if you want to go deeper into programming is How to Design Programs. So I highly recommend you go through this if, for example, during the break after this semester is over. But yeah, this is a really good book if you want to continue reading about other stuff in programming. Okay, so this is going to be the end of this lecture. Thank you for watching.